Good morning and welcome to Wednesday. Today we are going to go back up in your notes and take section 3, which we skipped for a couple of days. So if you go back in your notes to where it says percent composition, I think is on page 3. So just go back to that where it says percent composition, and we're going to talk about that here for a couple of minutes. The first thing I want you to do is to answer these questions on your own. Pause the video so you have time to take a minute and answer them. So a percent is actually a part of the whole. So it's just a part of the entire thing. The equation for calculating percent is written right there. It's just the part divided by the whole times 100. So back to that question about your 88% on a test. That means you got 88 out of 100 questions correct, if there happen to be 100 questions. If there only happen to be 50 questions, it means you got 44 out of the 50 questions correct, which also calculates out to 88%. If there were only 25 questions, well, that means you got 22 out of 25 for your 88%. But it's just the part of the whole. So it kind of works like a fraction, except you're just dividing that fraction instead of leaving it as a fraction. And to answer this question, how would you calculate the percentage of people in class wearing glasses? You would count up the number of people wearing glasses and divide that by the total number of people in the room, and then multiply it times 100. Because when you do the division part, you get a decimal point, and then we multiply times 100 to make it not a decimal anymore. But that's basically what a percent is. When we talk about percent composition, it still is a percentage, but it's a special type of percentage. It is the percentage by mass of every element in a compound. So basically you have a compound, say water, right? It's 2 parts hydrogen, 1 part oxygen. We can figure out the percent composition of both of those parts by taking the mass, which we get from the periodic table, and dividing the part by the whole. We're going to do an example here in a minute, so that makes more sense. The equation for percent composition looks like this. It's just the mass of an element in a compound divided by the total mass of the compound times 100. So very similar to the just general percent equation, except now we're talking about a specific thing, not just in general. And we usually round our answer to 2 decimal places when we do these problems. Another thing to remember, as kind of a way to check yourself, is that the total percent composition of a compound will add up to 100% or very close, depending on rounding. Remember, we just talked a second ago about how you have to round to the 2 decimal places, but depending on rounding, it might not be exactly 100, but it will be super, super close, 99 point something. Very rare. No, it shouldn't be any more off than that. If you get a number that's further away than 99, you probably should go back and check your answers, because it probably means you have done something incorrect. All right, so let's do a couple examples here. As usual, forgive my writing with the pen. But it says, find the percent composition of carbon in the following. The first one is some sort of organic compound. Usually if you see OH at the end, it's an alcohol. I'm not 100% sure what this one is off the top of my head. But we can see it's got 3 carbons, actually 8 hydrogens, 7 here plus 1 here, and 1 oxygen. So in order to find the percent composition, we have to do two things. First, we have to find the mass of just the carbon. Well, if you look on your periodic table, the mass of one atom of carbon is 12. So if we have 3 carbons, that is, let me turn my pen on, sorry. So we have 3 times 12, which is equal to 36. So that's grams. That's the mass of the carbon. The next thing we need to do is figure out the mass of the entire thing. So we have our 3 carbons, 3 times 12, we got that. Then like it says here, we add them up. We have 8 hydrogens. Mass is 1. So 8 times 1 is 8 grams. And then we have 1 oxygen. Oxygen is 16. So 1 times 16 is just equal to 16. So we have grams. So we have 36, 8, and 16. We add those together. We get 20, 34, 5, 60 grams. It's a really bad 6. Oh well. So to do the percentage of carbon, we take the 36 grams of carbon divided by the 60 grams of the total. And that equals, I forgot to pull out my calculator, 0.60. Then we multiply that times 100, and we get 60%. So this compound here is 60% carbon by mass. So 60% of the weight of this right here is carbon. All right, let's do the same thing with the carbon dioxide here. This one's a little bit easier. We have 1 carbon, which is 12 grams. We just looked that up, right? We have 2 oxygens. Oxygen is 16. So 2 times 16 is equal to 32 grams. So when we add those together, 12 plus 32, we get 44 grams. Then we can divide. Carbon is 12, it's the part, divided by 44, which is the total. And 12 divided by 44 is, hang on, getting out my calculator again, 0.27. We times that by 100, 27%. So 27% of carbon dioxide is made up of carbon. So percent composition, fairly easy. You just got to divide, right? Y'all can do that. Here are some practice problems that you need to do for your homework tonight. Make sure you bring them to class tomorrow. We will go over them. All right. Sorry, I had to go back and look at that again to make sure it was the right thing. We're moving on to section 7. It's near the end of your notes, page 8 or 9 maybe. We're going to talk about molecular and empirical formulas. We're just going to define them today, and then tomorrow we will get into more detail about how to calculate them. So, first, some definitions. Molecular formula is the group of element symbols with subscripts which represent the actual composition of a molecule. So there's a couple examples there. H2O, there's sodium carbonate there, NaCHO3. That one, the next one is glucose. You might remember that from photosynthesis. C6H12O6. So these molecular formulas show the actual number of every atom found in a molecule. They aren't simplified, they aren't anything. So water is 2 hydrogens, 1 oxygen. Glucose is 6 carbons, 12 hydrogens, 6 oxygens. If we could look at one single molecule, that's what we would see. That is the molecular formula. Now, the empirical formula is a little bit different. It's basically simplifying. So you take that molecular formula and you simplify it to its simplest whole number ratio. In order to find that molecular formula, we basically find the largest common denominator of all those subscripts and then reduce. So it's just like reducing fractions, except this time we're reducing formulas. Sometimes they'll equal each other, the empirical formula and the molecular formula. So if we go back for just a second, like this one, subscript is 2, subscript is 1. There's no way to simplify that. So the molecular formula and the empirical formula equal each other. This one over here, we've got 6, 12, and 6. Each of those are divisible by 6, right? So we can reduce this, and actually it reduces. So if we divide all those by 6, we get CH2O. That's the empirical formula for glucose, with those numbers reduced to their lowest common denominator, or least common multiple. I don't know the terms. I just know how to do it. So that's the empirical formula. All right, so let's try some examples. Here's some molecular formulas. Let's figure out the empirical formula. That first one, super easy. We've already done it. We said between 2 and 1, there's no reducing that. So the empirical formula is exactly the same. This one here, this is hydrogen peroxide. See how both subscripts are 2? We can reduce that, right? They're both divisible by 2. So we end up with 1 hydrogen, 1 oxygen. 1-to-1 ratio. Glucose, we already did. Divide all those by 6, and you get C1H2O1. Just remember, we don't have to write the ones. Number 4, this is methane, in case you cared. 1 carbon, 4 hydrogens. There is absolutely no way to reduce that. 1 and 4 is what it is. Number 5, though, that's hexane. We can reduce that. We've got a 2 and a 6. Both of those are divisible by 2. So we end up with CH3. 6 divided by 2 is 3. And then that last one there, C8H18. Both of those are just divisible by 2, right? That's the smallest number. So it will reduce down to C4H9. So those are the difference between the molecular formulas and the empirical formulas. Basically, you're just finding the least ratio of the elements to find the empirical formula. So that's all I had for today for video. For homework, finish those percent composition problems that were previously in your notes. And also I have a video for you to watch, another video on something completely different, but kind of a preview of what we're going to be doing next. So look for that in Canvas. It will be available to you this morning.